Hey guys, so today we are going to try to understand some of these stoichiometry and some types of calculations that are associated with it. So why wait? Let's get on with it. So we'll try to understand the mass and volume calculations and molar calculations and using two equations at least. So let's start with a very basic equation CH4 plus 2 oxygen, 2 carbon dioxide, 1 carbon dioxide and 2 water. Now what is reaction stoichiometry? Basically it wants to tell you about the quantitative relationships among the substances as they participate. So you know that there will be some set of reactants which are going to react in a reaction, and there will be some products. Now, there are two numbers that you should not get confused with. What are those? First is the coefficients. So coefficients are about to tell you how many molecules, you can say, how many, not number of molecules, but how many of the reactants are going to be participating, and the subscripts tell you the number of atoms in a compound. Now, these can be used in a variety of forms. Let's try to first write them down. So you have 1 mole of methane CH4 reacting with 2 moles. So this is the first kind of information that you can get from a reaction. 1 mole of methane, 2 mole of oxygen. Again, 1 mole of carbon dioxide and 2 moles of water. Now with this information you can go further. So you can calculate the mass of these reactants and products that are going to react. Now this is not needed, so I'm just going to erase it away so that we have more space to talk about these. So let's see the second kind of information that you can get. So CH4, that's 12 mass of carbon, 1 is mass of hydrogen, 12 plus 4 is 16. So we know 16 grams of methane will react with 2 molecules of oxygen, right? So 1 atom of oxygen is 16, 2 atoms of oxygen is 32, 2 times 32 is 64. So 64 grams of oxygen. Again, carbon 12, 32 is 16 times 2 is 32, 32 plus 12, 44. So 44 grams of carbon dioxide. And again, 2 times 18, I'm just doing it, 2 times H is 2 into 1 plus 16. So this is how you got to do 2 into 1 plus 16, right? So that brings you to 18 times 2, that is 36 grams of water. So this is the second information that you can get. Now, a majority of the reactants here are gases, right? So generally you'll find a small g written next to the reactants or the products, that would be gases here, right? So at standard temperature and pressure, you know 1 mole of any gas occupies 22.4 liters. So you can say 22.4 liters of methane reacts with 2 into 22.4, that is 44.8 liters of oxygen, and again to give you 22.4 liters of carbon dioxide. Now, this was not an aqueous case, right? Now, you see a variety of information type questions can be asked based on this information. For example, they may say, how much methane would be consumed to produce 10 liters of, how much methane would be consumed to produce 10 liters of carbon dioxide? So you know, how do you solve this question? Let's go a little bit. So you already know a bit of information about that. 22.4 liters of methane gives you, gives you about 22.4 liters of carbon dioxide. So one would give 22, one would require, again, how the question was, how much of methane will be there in how much methane is required for 10 liters, right? So for 1 liter of carbon dioxide, you have 22.4 liters of methane, right? And hence for 10, you have 22.4 into 10 liters of methane is required for 10 liters of carbon dioxide. So these are some types of calculations that can be done using the basic stoichiometry. Now let us look at this problem. So the problem basically wants to calculate the volume in liters and in milliliters of a 0.324 molar solution of sulfuric acid required to react completely with 2.792 gram of sodium carbonate. So what's the basic information available to you? 1 mole of H2SO4 reacts with 1 mole of Na2CO3. Now, first of all, you need to calculate the mass because the question tells you 2.792 gram of sodium carbonate. So, the first step is write the masses. So, 2 times 1 hydrogen plus sulfur is okay. So, 32 plus 16 times 4, that is 64. So 34 plus 64, that is 98. So you have 98 grams of H2SO4 reacting with 2 into 23, right? That is sodium, plus 12 plus 16 times 3, that is 48. That is 106 grams. So 106 grams of Na2CO3 requires 98 grams, right? Now remember, you have to calculate everything about sulfuric acid. So you will say 2.792 gram of Na2CO3 will require 98 by 106 into 2.792. This comes to 2.581 grams of H2SO4. Now the question was asking about volume in milliliters and liters. Now let's convert this into moles. So we are starting the second part, right? So 98 grams of H2SO4 was 1 mole. So 2.581 will be how many moles? So 1 upon 98 into 2.581. That comes to 0.0263 in moles. Now, let's have now the third part. Now, why the third part? Because the question says that the availability of sulfuric acid is 0.324. That is a molarity, right? Now, what does molarity means? Moles per liter, right? It's LITER. So let me just correct that. Right. So what does that mean? That means 1 liter of sulfuric acid has 0.324 moles. Now, you have been asked to find out, let me just use a brighter color here, how much of volume of sulfuric acid will have 0.0263 moles. So let's bring that as a denominator. 0.324 will have 1 mole, right? But how many do you need? You need 0.0263. So 1 by 0.324 into 0.0263, right? That will have 0.0263 moles. Now if you do the maths, 0.0811 liters, right? Now you have been asked volume in liters and milliliters. Now this is not a liter, so let's just write this in milliliter. How do you write this in milliliter? 1 liter has 1000 milliliters. So just make the decimal jump 3 points, right? So it comes to about 81.1 ml of H2SO4 solution of molarity how much? 0.324. So this comes to be your final answer. So I hope this helps. How do you exactly use stoichiometry to calculate a lot of stuff by using a simple equation? Thank you.
If you're looking for similar topics, check out our other videos and don't forget to subscribe.